Simplifying radical part 2, we're going to look at higher roots, so cube roots and fourth roots, fifth roots, stuff like that. We already did square roots. It is the same principles we'll be using. We're more familiar with square roots, so that's what we started. We start with that, and hopefully we can apply some of those ideas to higher roots. So we're going to do the same thing we did before. We're going to start by simplifying with constants within the radical. And instead of finding the perfect square, we're going to find perfect cubes and fourth powers and fifth powers, or whatever we might need. We're not quite as familiar with those. And then we'll really do the same steps as we did before. So let's go ahead and look at our first examples and follow through these steps to help us solve these. So we want to take the cubed root of 40. And so instead of finding perfect squares, because we're not dealing with square roots anymore, we're dealing with perfect cubes, we want to find perfect cubes. So let's review our perfect cubes. So perfect cubes, we're thinking like 1 cubed, 2 cubed, 3 cubed. So 1 cubed is 1, which we're not really going to use that. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. We don't always get this high. 9 cubed is 729, I believe. And then 10 cubed is 1,000. Maybe you commit these to memory, or they're easy to find if you have a calculator especially, but these are helpful. And again, we really won't use this one because we don't need to know if 1 goes into it. So we want to find a highest, since we're doing a cube root, a highest perfect cube that goes into 40, and it's our first one there. We can write this as the cubed root of 8 times 5, because 40 is 8 times 5. And what we're going to do is we're going to split this up just as we did before with perfect squares. The cubed root of 8 times the cubed root of 5. Well, cubed root of 8, what times itself 3 times gives me 8, and that's 2. And so we have 2 times the cubed root of 5. Please don't forget to put our index of 3 up here. I've seen that before. We get used to doing square roots where we don't have to put anything, but there is our simplified version of the cubed root of 40. Let's move on to 500. Cubed root of 500, 8, 27, I believe 125 goes into there, so let's divide that. We can look at 500 divided by 125, and that's 4. You get 0. So we know the perfect cube 125 goes into this, so we're going to rewrite this as the cubed root of 125 times the cubed root of what was left over, which is 4. And I told you not to forget your thing and your index there, and I forgot it almost. So cubed root of 125, what times itself 3 times is 125, that's 5. So we have 5 times the cube root of 4. Now we have to be careful. Some people want to be like, oh, I know the square root of 4 is 2. Well, this is not square root, it's cubed root. So there we don't have a whole number cube root of 4. So don't try to simplify this to 2 because it is not a square root, it's a cube root. So there's our answer for that one. Our next one is a fourth root. And so it helps to be somewhat familiar with perfect fourth powers. We won't go real far with this one, but actually, obviously 1 to the 4th is 1. 2 to the 4th is 16. 3 to the 4th is 81. 4 to the 4th is 256. And so we want to figure out, do any of those go into there? So let's try them. If we do 16 into there, 16 into 486, if you have a calculator, obviously that would be helpful. This goes 3 times, and we get 848, and bring down, so 16 doesn't go to 6, so it's not 16. Let's try 81. So 81 into 486. I guess 6 is our only option there if it would work. So 6 times 8 is 48, and it does work. So 486, 81 goes into it, so we want to rewrite this as the 4th root of 81 times the 4th root of 6. And 4th root of 81, that's 3, times the 4th root of 6, and that is our simplified answer. And so that is simplifying constants within radicals. So we did a couple cube roots, 4th roots, 5th roots would be similar. Same idea, but using perfect, or numbers that are something to the 5th power. Let's go ahead and look at simplifying variables within the radical. We're going to start the same way, simplify it into its own radical, each variable into its own radical. So let's just go ahead and start with this example and follow our steps here. So we're going to write this as the cubed root of w squared times the cubed root of x to the 6th times the cubed root of y to the 10th times the cubed root of z. Now, remembering what a perfect cube means, and this one is a perfect cube, or 4th root, 5th root, so it means what times itself 3 times, multiplied by itself 3 times, gives this number. So is there anything that multiplies by itself 3 times to give us w squared? Well, no, we can't do anything there. So this is just the cubed root of w squared still. What times itself 3 times will give x to the 6th? Well, I know that x squared times x squared, times x squared is x to the 6th. So x squared times itself 3 times gives x to the 6th. So this would be the cubed root of x to the 6th is x squared. This one isn't easily doable, neither is this one. Actually, this one we can't do anything with, so we're going to jump to step 3. Split any variables that can't be simplified easily into 2 factors. One being the perfect cube, and the other its leftover. So we did this before. So is there a perfect cube here that does work that we can split this into? So really the way that we determine this is, what number does 3 go into that's less than 10? Well, 3 goes into 9. So what we're going to do is we're going to split this into cubed root of y to the 9th. And then what's the leftover? Well, we have a 1 left over. So the cubed root of y to the 1st, or just y. And then we have the cubed root of z. So this one here we can simplify. The other ones we can't. We worked through those already. So what times itself 3 times gives y to the 9th? Well, that would be a y cubed times y cubed times y cubed gives us 1 to the 9th. And so we know that this right here is simply y cubed. Just saving some time and space here instead of rewriting everything. So now that we're here, we simplified, and now we're going to combine. So we put things that aren't in the cube root outside. So we have an x squared and a y cubed. And then left inside the cubed root is a w squared, a y, and a z. And that's our answer. Our next one, we actually have a 4th root here, so let's work with this 4th root. And we're going to split this up again. So we have the 4th root of w squared times the 4th root of x to the 6th, the 4th root of y to the 10th, and the 4th root of z. if we can simplify them, if there's any perfect, if it goes in evenly, we want to. Actually, none of these do, so we're going to split them if possible. Nothing works here for this one because the 2 is smaller than the 4, so we're going to leave this as the 4th root of w squared. This one we can split this up, and we can split this up into w to the 4th times w squared. Sorry, I forgot the 4th root. Y to the 10th, we're thinking what number, really it's what multiple of 4 goes into 10, or smaller than 10, the largest multiple of 4 that's smaller than 10, and that's an 8. So we are going to write the 4th root of y to the 8th, and times the 4th root of what's left over. If we use up a y to the 8th, well, that's a y squared. And then last one we can't simplify, that's the 4th root of z. And now we do our simplifying. Well, I just noticed I wrote w's in here instead of x's, so these should be x's. Sorry. This simplifies. The 4th root of x to the 4th, that's just x. So that's just an x. This one simplifies. What times itself 4 times gives us y to the 8th? Well, that's y squared. And the others we can't simplify, so we're left, we're separating or simplifying and combining, so we have on the outside x, y squared, and within our 4th root we have a w squared, an x squared, a y squared from right here, and then a z. And that's the simplified form of that. And then we have our last one here, which we're going to kind of squeeze in down here. We have a 5th root, so it helps to know our 5th roots. So 1 to the 5th is 1, 2 to the 5th is 32, and 3 to the 5th is, I'm not sure what 3 to the 5th is, but I see that 32 goes into 64. So we can do that. So we're going to split this up. We have the 5th root of 32 times 2 gives us 64. So 32, and then the 5th root of 2, because 32 times 2 is 64. And then we have the 5th root of a to the 12th, the 5th root of b to the 10th, and the 5th root of c cubed. And so we know that this is 2. Actually, yeah, we know this is 2. And then we have the 5th root of 2 left over. Here, this is a 5. It's not a, looks like a 6, but it was supposed to be a 5. We can split this up into the 5th root of 5. Sorry, the 5th root of a to the 10th. And then the 5th root of what's left over. I'm doing the 10th because 5 goes into 10, and then this is a squared. This is b to the 10th, which that works, so we can simplify that. What times itself 5 times gives b to the 10th? Well, that's b squared. And then this last one doesn't simplify, and we can definitely know that because the 3 is less than the 5, so we have the 5th root of c cubed. And then we want to do some simplifying if possible. This one here can simplify. That was a lot like this over here. So what times itself 5 times gives a to the 10th? Well, that's a squared. And now what we'll do is we'll combine. We'll put the things that aren't under a radical out here. So we got a 2a squared, b squared. And then we left over for under the 5th root, we have a 2, an a squared, and a c cubed. And that's our answer for that. So the more you practice these, the better that you'll get at these. And that's simplifying radicals with higher roots.